Alright, what's up guys? In this video we're going to pick up some multivariable calculus, and we're going to be talking about double integrals. So I'm going to show you guys how to evaluate this double integral here from 0 to the power over 2 from 0 to y times cosine of y dx dy. So this is more or less just an iterated integral. It's already set up for us. We just got to solve it or evaluate it. It's a better way to say it. Alright, so remember, for the double integrals, in this particular case, we're going to be integrating with respect to x first. That means we're treating y as a constant, and we work our way from the innermost integral here to the outermost one. So let's do that. So it's going to be from 0 to y times cosine of y, and it's going to be dx. That's what we're going to be integrating with respect to first. So if we integrate dx, we'll just simply get x, and it's going to be evaluated from 0 to y times cosine of y, and we know that it's just going to give us y times cosine of y, because sticking in the 0, we're just subtracting 0, and obviously we're not taking anything away. And so when we integrate with respect to x first, we will get y times cosine of y. So now we move on to the outermost integral here, and it's going to be from 0 to pi over 2. It's going to be y times cosine of y dy. Okay, so we apply integration by parts here, and this is a very easy one, but we'll go through all the steps. So remember that integration by parts is the integral of u dv is equal to uv minus the integral of v du. So we'll need to determine a u and a dv. So dv, u I'm gonna let equal y, and dv is everything else. So dv will be cosine of y dy. We now need du, which would be dy, and we need v, which is the antiderivative of dv. So that's the antiderivative of cosine of y dy, which we know is positive sine of y. Now we use our integration by parts formula. So we'll get y times sine of y, and it's going to be minus the antiderivative of sine of y dy, and that's going to be integrated from 0 to pi over 2. So we know that the antiderivative of sine of y with respect to y is just going to be negative cosine of y. Now remember that the integration by parts formula already has a minus sign in between, so we would have two minuses or two negatives, thus making it positive. So once we've done the integration, what we'll have is y times sine of y, and then this will just be plus cosine of y, and it's going to be evaluated from 0 to pi over 2. So all you do next is apply the fundamental theorem of calculus. You sub in the pi over 2 first, and you subtract from that whatever you get when you plug in 0. So this would be pi over 2 times sine of pi over 2 plus cosine of pi over 2. Okay. So this is just going to end up giving me pi over 2 plus 0, which we know is pi over 2. That's what we'll get when we stick in the pi over 2. When we stick in the 0, well, we'll get 0 times sine of 0. So we know that side is 0. And then this would be plus cosine of 0. Cosine of 0 is 1. So if we sub in the 0, we'll get a 1. So that means that our final answer for this iterated double integral, which we'll go ahead and write down, so the integral was initially from 0 to pi over 2, from 0 to y times cosine of y, and it was dx dy. So the answer for this is just going to be pi over 2 minus 1. And that's it. So just a short little double integral. Not much to that one. So that's your solution. So, all right, let me know if you got any questions, and I will see y'all next time.